In this video, we will discuss about pitot tube, also called as insertion meter. Okay, like orifice meter, also called as variable head meter. The same way, pitot tube is called as insertion meter. Okay, and this pitot tube is majorly used to measure the velocity differences, velocity head of the flow. In the previous orifice and venturi meter, we have measured the pressure difference, and here in this pitot tube we will measure the velocity difference, velocity head of the flow. Okay. Now here in this pitot tube, a pipeline is there, a small pipe is there in which the fluid is flowing in this direction, and at the center of the tube we are attaching one manometer here. At one side of the tube, manometer is attached, and to the two ends of the manometer, two pipes are being inserted. Okay, two pipes are being attached to the manometer. One pipe is parallel to the flow of the fluid, and one pipe is perpendicular to the flow of fluid. Okay, the two pipes are there, and these two pipes are attached to this pipeline such a way that one pipe is perpendicular to the flow of fluid and one pipe is parallel to the flow of fluid, and the two ends of the pipes are attached to the manometer. Okay, setup of this device is such that a straight pipeline is there in which the manometer is fixed to two pipes, and the two pipes are being inserted in this main pipeline such a way that one end of the tube is perpendicular to the flow of fluid and one end is parallel to the flow of fluid. This manometer is used to measure the pressure difference, and velocity is again calculated at two different points here in the pitot tube, in this tube. Okay, now as you all know, the basic principle of Bernoulli theorem, or whatever we have seen in orifice and venturi meter, we have seen that whenever a fluid velocity is increased, the pressure head decreases. मतलब अगर हम velocity increase करेंगे fluid की, तो pressure will be getting decreased. This is already said by in the Bernoulli theorem, and we have got the formula as delta Hp is equals to u square by mu square by 2g. मतलब pressure head difference is nothing is equals to velocity by 2g. Okay, so by taking this equation, again we are getting one derivative of this one, but in here the derivative mainly focus on the velocity. Okay, so this is a main construction, that is construction is such that a main pipeline is there, and here in which the fluid is flowing, two tubes are fixed, so two tubes are fixed to this pipeline such a way that one tube is perpendicular to the flow of fluid and one tube is parallel to the flow of fluid. The two ends of the fluids are attached to a manometer. Okay, this is the construction, and principle here is this is mainly used for measuring the velocity head or velocity difference in the flow. Okay, and by using Bernoulli theorem we are going to calculate the velocity difference. Okay, now working is there, that is fluid is flowing in a pipeline in such a way that the fluid, when it enters the perpendicular position, there will be a difference in velocity at two different points. That difference in velocity is calculated by using Bernoulli theorem, and the equation which you get to calculate is u square is equals to cv under square root 2g delta hp. Here CV is a coefficient difference and U is a velocity difference. Okay, to understand this pitot tube in a basic manner, to understand this phenomena of pitot tube, what we are doing is basically to understand this phenomena, where a pipeline is there. Okay, in that pipeline the fluid is flowing continuously. Okay, and when I insert one tube here in perpendicular position, when I insert one tube here, what happens, the fluid will continuously flow, it will strike this bending area, then it will move upward in this direction. Okay, it will move upward in this direction. The velocity of fluid at this point, that is v1, we are keeping as v1, and the velocity of fluid at this point v2 is completely different. So this difference in velocity v1 and v2 is calculated by using the Bernoulli equation. Okay, so what happens when a fluid is continuously flowing, it is and striking the movement here, it is striking the constriction part. Okay, it is striking the bending part over here, and it is moving upward in this direction into a particular height. ओके तो यहाँ पे एनर्जीज कन्वर्ट हो रहे, द फ्लूइड इज कमिंग विद अ प्रेशर, certain pressure and certain pressure energy and certain kinetic energy. Okay, the fluid is continuously in a motion, so it is coming with a certain pressure energy and kinetic energy. Suddenly it is striking over there and it is moving to a particular height such that till where it moves, till the kinetic energy converts to the potential energy. Okay, till the kinetic energy gets converted to the potential energy, the water level will move up, matlab the fluid level will move up. After a particular level it will stop here. Okay, when it will stop, when the higher potential energy is reached. Okay, so to understand this thing, the fluid is coming with a certain pressure energy, kinetic energy, it is coming to a particular point and it is again moving upward in a pipeline inserted here such that it will reach to a particular height. Okay, that height one is a potential energy and hence three energies are working over here in this diagram. Okay, the same diagram reflects again here. A fluid is continuously fluid is striking over here and it is moving, this is upward position, it is moving to a particular height and this difference in velocity is noted down and it is derived by the equation, Bernoulli equation. You get the final equation as u squared is equals to cv under square root 2g delta hp.